this is the end for me. Drinking beers on the porch, contributing in both sports. It's always Australia Day. It's 308. It's 308. It's 308. It's 308.
Let's see, is this a good audio level for the music and the microphone? Can you all hear okay? Should I turn down the music? It's good? No? Not good? Good audio? Okay. Cool. So, sorry, I lied. I forgot to actually start playing the playlist for the class. This is actually my Discover Weekly. So I'm gonna put on the playlist for the class. Marcus still did a great job, but so let me go ahead and do that. It's a little bit higher energy. So, okay, so how's everyone doing today? You all doing all right? Let me see. Oh, I don't have the chat on this one. I guess I shouldn't use this one. How about this one? No, whoops, that's the wrong way. This one? No. This one? Oh, is this one? Someone chat. Are you chatting? I don't know if you're chatting or not. Do some chatting. No, it's not working. Okay. Damn, it's been too, oh, I'm gone now, right? Okay, well, I'll just use this one. So, what kind of puppy is it? I love dogs. Chat, 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 chat. So I hope everyone's doing okay with everything going on. Yorkie poo. Cool. I don't know what a Yorkie poo looks like, but so yeah, the playlist was on in the chat, so everyone should be able to add stuff to it if you want to add to it. I feel like this song is louder than the other one. Is this louder? Fancy. Probably expensive too, right? So again, just let me know if the audio is like way off. So speaking of animals, I have a task for everyone in the class. So I want you to start thinking about a weird animal. So a weird animal. Everyone knows of a weird animal, right? So like there are animals like sea pigs, for instance. Dog horse, apparently. I don't know what a dog horse is. Platypus, very strange. There are, what else is strange? I don't know, I'm just like going blank right now. What about like those like tube things in the ocean that like flap in the wind, or I don't fucking know. What about a tardigrade? You know, those like microscopic, like bear looking things with like the little mouth, and they can like live on Mars and stuff. So I started thinking about that. And then the second thing I want you to start thinking about is I want you to think about a really, really awful, awful, awful job. A job that nobody wants to do. So you're thinking about a weird animal, ideally one that is like less well known. And then the second thing you're thinking about is a really awful job. So like, such as like, I don't know, people that clean the sewers, or like the job of, I don't know, just any awful job. Something really bad that no one want to do. So yeah, that sounds like a weird animal for sure. So I want you to think about those two things, because I'm going to ask you to share those in a little bit. And so today we're going to talk about, what are we going to talk about? We're going to talk about custom functions. So we were supposed to do that last time, and then we got a little bit off track. Stupid hair. Okay, there we go. I feel like I'm in a good mood for some reason. I don't know why. I feel like I should be in a terrible mood, and I was earlier. It's this great music, very energizing. So anyways, we're going to talk about custom functions, and we are approaching the end of the semester. So I hope that everyone submitted any late work that you had today, and you completed your game mission 2. So I hope that's in a good state. So go in there and check everyone's game mission 2, and go ahead and figure out which one is the best executed. And I want you to give it a reaction like you do, if you remember how we did it before. So whichever one's best executed, just vote for one, and then next time in class, remind me, and I will give something away for whoever has the most votes for best executed assignment. Okay, so we are going to talk about custom functions today. Custom functions. So can someone like try to define a function? Like, what is a function? Not in code, but just in general. Can someone like define that for us? Function, F-U-N-C-T-I-O-N. By the way, this is like the best flavor of Monster Energy drink. The orange Ultra Sunrise. Just tastes like orange soda. So, can anyone define function? Function, function, function. Or like, what's an example of a function of something? Like, what's a function of a toothbrush? What is a function of a toothbrush? Just any function that a toothbrush does. So brush teeth, right? So toothbrushes have the function of brushing our teeth. Possibly like cleaning stuff, maybe also cleaning other stuff like the bathtub or something. And so like what's a function of like a shoe? What's a function of a shoe? S-H-O-E, shoe. Tells computer a specific thing it's supposed to do. Whoa, your shoes are different than mine. But yeah, that's right. Protection, to protect your bare feet, to sometimes to like make you taller, or like project your mounts for comfort. They make it like it's more comfortable to like walk on the ground in a shoe rather than like stepping on broken glass outside. So those are all functions of shoes, and previously functions of toothbrushes. So these are things that a thing does, right? So like an action, for instance. And so Linda said tells computer a specific thing it's supposed to do. And so I'm gonna turn this down a little bit for myself. And so when we think about functions, we've actually been using functions in processing already. So we have functions like, and this is not real code that will execute, like an ellipse, right? So I'm not gonna finish it, but like ellipse is something that happens. So when you write ellipse and you give it the right parameters, what happens is processing draws an ellipse. Same thing with like rect. Rect is a function in processing. When you write rect and you put in the right parameters, it draws a rectangle. There's also a function like random, for instance. There's a function like size. So does anyone know what all of those functions have in common? Like in terms of how they're written? Can anyone pick up on the pattern? So like, let's say this is, I'm just like making this up. So like that's an ellipse, which is a function. There's also like rect, let's say, and I'm just making these up. There's also like size, right? It's a function. What other functions are there? Random. And the numbers don't matter here, they're just examples. And so what do all of these functions have in common? So they must have a parentheses that follow. So that's a good catch. So we have like a word here, right? And then we have parentheses. But there are also some that don't involve parameters inside the parentheses. So there's like, for instance, no stroke. So like this will draw your shapes with no outline. And so as Marcus picked up on, we have all of these are like the word that represents it, followed by these parentheses, and then sometimes they have parameters inside of the parentheses, so you have to give like values that tell it how to do the thing, and sometimes you don't. It just depends on what it is. And so what happens when we write these functions out is it's doing something called calling the function. So when I say calling the function, I mean that there is some code in processing somewhere in a file somewhere, and it has a definition of like there's code that this refers to that tells it what to do. So this is basically like calling up a function rect. So like it finds the code for rect and it does whatever it's supposed to do. And so functions do stuff, right? So what we're going to do today is we're going to make our own custom functions. So these are just examples of built-in ones. So we're going to make our own. So the first thing we're going to do is we're going to do our setup and void draw. And so these are actually functions also. So these are actually functions that we are defining, and they're running in a very specific way because processing knows how to run them. So you have these parentheses. So this is actually a definition. So the first thing when you're creating a function is the type of function that you're creating. So in this case, and I mentioned this like briefly when we first started doing, when I first started showing you setup and draw, is that void is the type of function that setup is and that draw is. And so let's see. So let's just go ahead and give this a size. I'm going to give it 720p. That's 1280 pixels wide by 720 pixels tall. And then so this is a function, and this function size will basically create the window. And so there are functions which return a value, and there are functions which do not return a value. So what I mean by that is I could do, for instance, let's see, I could do print line, and I could do a random. So random is a function built into processing, and you can if you put in one parameter, like let's say I have 500, this will give me a random value between 0 and 500, but it will not include 500. So this is what we call a return function. So two kinds of functions generally. There's a void function, which does not return anything, it just does something. And then there is a return function. The return function will actually give back a value. So what happens is we have this print ln function, which this will be a void function, meaning that it does not change into something else, versus this random function, which will actually change into something else. So like it will turn into a random value between 0 and 500. So when we actually run this code, this will turn into like 300 or 100 or 55 or 76 or whatever. And so if I run it, I can see that it's giving us these return values, right? So it's giving us that random value between 0 and 500, not including 500. So like if I was to do something like, and I don't even know if this will run. So that won't work, but like this basically does not change into anything else. So like if I was just to put like a random 500 here, this would be like basically like, when it runs this code, it just is like writing like 300 here, or like 250. That's 350. But it doesn't do anything because it's meant to be used with other stuff. So like, you know that this is something that is going to return and basically convert itself into a value. So does that make sense? How some things don't change into something, they just do something, and other things do something and change into something. So this is a return function. It returns a value. And this is not a return function. It just does a thing without returning any value. So nothing else happens here. Does that make sense? And tell me no if it does not. Cool. Other people, does that make sense? It's okay if it doesn't. Okay. Cool, cool. So if we want to actually define a function, so the first thing we're going to do to define a function is we are going to, so what we're going to do today is, we're going to actually create, is that good or bad? The hypnotization, hypnotizing. Okay, cool. So let's say that we wanted to create a something that will roll some dice, for instance. So like what's a function of dice? What's a function of dice? What do they do? Or what can they do? What is their purpose? Or what is one of their purposes? So again, I'm like white. So showing odds. So yeah. And how does it do that? So like a random number generator, right? So like maybe you want a random, so like traditional dice are like 6-sided, right? You have the number 1, 2, 3, 4, 5, 6. And so you can roll any value between 1, I don't know why I did, this is 1. It's a weird way to do 1, and 6. So listing an amount of dots you get on a roll. So yeah, so you basically like throw them, right? And it gives you that random number. So that's like the primary function, is to give you a random value between the lowest number. So like if you have 2 dice, for instance, what is the lowest value you can get with 2 dice? So with 2 dice, the lowest value, if you roll both of the dice, so 1 is for 1, right? And then 2 would be for 2 dice. So when you have, you could roll 1 with each die, and that's 2 total. So if you have 1 die, you roll it, and then you get 1 to 6. If you have 2 dice, the plural of die, then you get between 2 and 12, right? So what we're going to do is we're going to actually make our own dice roll function. So what we wanted to do is, I'm going to first make it a, we can make it like a fixed, we can make it a void function first. So when we want to make a function, we have to say the type first. So that type is basically the return type. So if you want it to return nothing, it's void. Void is the type. So I would write void, and we're defining it right now. And so I'm gonna call this function roll 2 dice. And so this is defining a function called roll 2 dice. And right now it doesn't do anything. And so if I could write print line in here to get a message in the console. And so in the print line, I gave a string, a message for the console. You rolled 2 dice, sort of. So right now it's not actually giving you a value, it's just showing you the purpose. So if we run this, what's gonna happen is absolutely nothing. The reason why nothing is happening is because we have defined this function, but we have not called this function. So we have not executed it, right? So if we want to execute it or call it, we need to use the name somewhere else. So like here we're calling the size function. So if we want to do it once at the beginning of our sketch when it runs, I can call that function by writing its name, roll 2 dice, open close parentheses, semicolon. So when I run this, what will happen is at the first time the sketch runs, it will go through setup, it'll set up the size first, and then it will search for this function, the definition of this function, where it's defined. So it's defined here, and it will execute the code inside of the parentheses, or inside of the curly brackets, I should say. So when I run this, you'll see this message once inside the console at the bottom. And so we see it once, it was called once, and it ran the code inside of there. So if I wanted to do it again, if I did it inside of draw, for instance, I could do roll 2 dice. And so now it runs once every frame. So it calls this like a bunch of times. And so this is useful because this allows you to write less code if you want to do something. Like say you want to do this so many times, right? And so now it's done it a whole lot of times. We only wrote this once, and yet it's executing it like 60 times per second, which is very helpful for us if we want it to roll that many times. So, but let's say that we want this to actually do something. So this is not going to be a game mission. So that was the last game mission that we finished. So we have, we're about to move on to the final project. So you will be able to use this stuff in there for sure. I'm sorry. Don't worry. You'll be able to incorporate your ideas. All right, so let's say that we wanted to actually roll some dice. So we could have inside of this function, we could, for instance, so like what is the data type for a dice roll value? Would it be like a string or a Boolean or an integer or a float, or what kind of value? And I wish I had some dice at hand, but I do not for some reason. I actually don't even know if I own dice. I'm sure I do. Dice are so much fun. This is kind of like dice, or die. It's kind of like a die. So like, if you wanted to add text to this, so like, I mean, I could display some text or something if I wanted to here. But like, what kind? Let's say you roll a die. What kind of value is it going to give you? Like, what would it be? A float or an integer? Would it be a Boolean? Would you want to play the game of the walking pixel? I mean, I could add that if I wanted to say that every time this function ran. I could do that. So Marcus said an integer, right? So it gives you a whole number, right? So it gives you a whole number and just a standard die, like 1, 2, 3, 4, 5, or 6. So if we want to have that here, we can write, let's say, so I can make a new integer called roll value, and then I could say equals. So I could either add a semicolon here and do it on a separate line, or I could just have it in the same line. So I could say roll value equals, and then does anyone remember how we use random? I mentioned it before. So there are multiple ways you can use random. You can use random with one value, and it will give you a random float between 0 and that value, but not including that value. Or you can put in a low number and a high number. So if this is for 2 dice, we would want to use the random function, and then we can put in the low number and the high number. So we said that the lowest possible number for 2 dice is what again? What was the lowest possible number? Two, right? And then what is the highest possible number for 2 standard dice? So they both go up to 6, right? So what would that be? So between 2 and 6 plus 6, right? I don't see anyone saying it, but I can write, so 12, right? So 12. So I could write 6 plus 6, or I could write 1 plus 1, just to do the same thing. Maybe this is easier to understand, because 1 plus 1 is 2, because that's the first die and the second die, and then 6 plus 6, that's the highest for each die as well. Now this is underlined because roll value is an integer, and this will give you a float. So one thing to consider is that this is the highest, it will give you a value up to this, but not including this. So you would have to add 1 to it to make sure that it includes everything below that. So like because what this will do is it will give you a float. So like it'll give you like maybe up to like 6.9, or sorry, 11.999 if you have it at 12, but it will not give you 12. And it will not round the value. So that's why you have to add 1 for the maximum value. And this is underlined because it is actually giving you a float. And so there's a type mismatch. It's like you're trying to use roll value, which is an integer, with a float that random gives you. And so we have to convert it. So we can convert it from a float into an integer by putting int beforehand. So this is actually a function. What this function does is this will take whatever's inside of the parentheses that's like a float, and it will convert it into an integer. So this is actually a return function, and it will return an integer. So it's an int function. So again, we have our random value. So the first parameter is, and I'm just gonna write 2 because it's 1 plus 1 each die, right? So the lowest possible value could be 2, and the highest possible value could be 12, and then we add 1 because it does not include that number. So that's why it's 12 plus 1. I know that's kind of confusing. So just remember, it does not include that high value. So this will give us between 2 and 12, including 12. So that's why we do 13. So I'm going to change this to say, and the value was plus roll value. So what this does is it declares an integer called roll value. It assigns that using random. So it gives us a random value between 2 and 12. We add 1 because it does not include 12. So now it does include 12. We convert it into an integer because it gives us a float. So making sure that it matches with roll value. And then we use print line, which will give us a line in the console, and it will give us this string, which is you rolled 2 dice and the value was. And if we do this plus and then our variable, it will give us the value as a number in the console. So let's see. So I'm going to comment this out so we just do it once to begin with. So now that we see here, we had inside of setup, we called the function once. So it created the size of the window, and then it called the function. So then it like skipped basically to line 12 and started executing all of this code, which ended up printing that line to the console, and the value was 5. So if I run it again, this time the value was 6. This time the value was 8. This time the value was 11. And so if I uncomment this out inside of draw, it will call that function every single frame. So now you can see we're getting values between 2 and 12, which is what you would expect when you roll 2 dice. What are your questions about what I just did? What were your what the fuck moments? Where were you lost? Tell me. I'm sure you have questions. Or things you are not sure about, or things you want me to re-explain. And if you don't have anything, just let me know that as well. Questions. Or no questions. You understand what this was? If we wanted to add more, would we just add another void? When you say add more, do you mean like more dice? So in this case, I basically like hard coded it for 2 dice. So that's why I gave it in the name. So we're actually going to make one where we can have a dynamic number of dice. So we're going to do that. What other questions people have? Or like what part didn't make sense? So maybe we can do the like 1 to 5, how much people are understanding it. So if you can just give a number between 1 and 5 in the chat. 1, I have no idea what you're talking about. 5, I'm an expert at this. Hello, Professor. Can we change the number of faces on the dice for the dynamic one? So we could, but I don't want to make it too confusing. Okay, so people are generally on board. So, special guests today. So let's go ahead and make the dynamic one. So we have our function to roll 2 dice. So we're going to have one to roll a custom number of dice. So this time we're going to make it so we can make it like, so I can make it roll number, So I'll just call it roll some dice. And so I'm making this also a void function, but we're going to change it a little bit and we're going to change it a little bit and a little bit. So we have, if we want to have a function where we actually give it values, so for instance, like when we run this print line, we have to give it something inside the parentheses. So it takes what's called a parameter that's passed into it. So when something is passed into something else, it actually declares something, a variable to use within it when it's running. So I could create an integer here called how many dice. And so when we call this function, so like if I was to call this function inside of setup, I would write roll some dice, and then I could say how many dice to roll. So when I call this, I give it a value of this type. So in this case, an integer, to indicate what should be passed into this value. So it basically declares a new function and takes the value of whatever you gave it inside the parentheses when you called it. So like in this case, if you give it the value of 5, it will declare a new integer called how many dice, and it will give it a value of 5. I know that's kind of weird. I hope it makes sense. And so we might do the same thing that we did before, where we have int roll value equals, I know, I hope your head's okay. So we can do the same thing we did above, right? Where random is gonna give us a float, so we need to use an integer, and then we're using the random function. And so the smallest number of however many dice we roll is gonna be based on the smallest number for 1 die. The smallest number for 1 die, for standard die, is 1, right? So 1 times the number of dice. So if you have 2 dice, the smallest number you can roll is 2, 1 for each die. If you roll 3 dice, then the smallest number you can roll is 3, because each one rolled 1. So it's 1 times the number of dice, because 1 is the smallest number you can roll, and how many dice is how many you're doing. So that's the smallest one. And then for the highest one, you do for a standard die is how many is the maximum value on one die. And so the maximum value for one die for the standard die is 6, right? And then you multiply times the number of dice. So if you roll 6 for 2 dice, that's 6 times 2, that's 12, right? So that's the number, the maximum value for a die times the number of dice. And so I will just copy this line and paste it into here. And so I'm going to comment this line out. And so I'm going to comment this one out. And so now we will only have one dice roll. And this will, let's say, I'm going to start off with 2. So 2 dice to roll so that it will give us still a value. And then also don't forget that we need to add 1 to this because it's up to that value, but not including that value. So we have to add 1 to make sure that it includes that value, which is kind of weird, I know. So this will give us a value between, potentially, if this is 2, between 1 times 2, so 2 is the smallest number for 2 dice to roll, and 6 times 2, which is 12, and then we just add 1 to make sure it includes 12. So I'm gonna run this, and it gives us a value in the bottom. If I run it again, and so the lowest value it will give us is 2, the highest value is 12. What if I do 3 dice? What is the lowest possible value for 3 dice? And what is the highest possible value for 3 dice? Standard dice. So 3 to 18, right? Because this would be 1 times 3 is 3, and then 6 times 6, or yeah, 6 times 3, I can't math. 6 times 3 is 18, and then we just add 1 to make sure it includes 18. And so if we run it this time, so we got 9 the first time, we got 10 the second time, 17 the third time, and sorry, I should just say you rolled dice, because that's because I copied and pasted it. So this will give us that value. So like, again, to go back over this, when you have a function that takes a parameter into it, so like inside the parentheses, you give a value of this type when it's defined, and it will take that value and pass it into this variable. When this function runs, it will create a new integer called how many dice, and it will give how many dice the value of whatever you put inside the parentheses. So once that happens, we declare a new integer called roll value, and then we give it a random value between 1 times the number of dice and 6 times the number of dice, and then we add 1 to make sure it includes that number, and then we use the print line to give us that value in the console. So the next step would be to, let's say that we wanted to have something where we actually create a return value. So remember so like int as a function and random as a function, it has a return value. So it will actually give you something back. So in this case, this is when we call roll some dice, it is a void function, meaning that all this does is execute the code inside of the function down here. It does not change this into something else. So when we run random, it actually replaces this code with whatever it gives you back. So we're going to make one where it returns a value. So we're going to return the value of the dice, right? So I'm going to say, since dice give us a whole number, I'm going to call it an int. So this is like when we declare it, it's the same way we declare a variable, except it's a function. So I give it the type, and then I give it the name. And so in this case, I will call it return some dice roll. That sounds weird, but that's what I'm going to call it. And so we're going to run it the same way that we did this one, where we had a value passed into it. So I'm doing it the same way that I did that one. And so it's telling me that there is an error here because I haven't returned anything. So we're going to fix that. So again, these functions are void functions, meaning when you call them, they don't do anything on that line. They just execute the code inside of the curly brackets. And then when we get to here, it's actually going to give us a value back. So when we call it, it will swap out where we called it for a value. And so I'm actually going to like copy the way we did this here. So where we had a new integer we created called roll value, and then we gave it an assignment based on a random value between 1 times one side times however many dice we have, up to 6 sides, value of 6 maximum times the number of dice plus 1 to include that number. And then instead of running this here, where we printed it to the console, we're going to return the value. So we're going to basically like teleport back a value whenever you call that function. So we would write return, and then after return, we write the thing that we want to return. So it has to be of the type of the function. So that indicates what type of thing we're going to return. And so we're going to return roll value. So what happens is if I do this here, I'll comment this one out. So I'm going to do, I could do a print line here, print ln. So roll, or not, so I called it return some dice roll. Weird name. So long. And then the number of dice. So let's say we roll 1 die. So what this will do is it will see this, once it gets to this line of code to execute, it will find this function, return some dice roll, and then it will run this. It will pass the value that we gave it, which was 1, inside of here. It will do the stuff we did to give roll value a random value. And then what it will do is it will return whatever roll value was, so the number, the random value, it will send it back and convert this into that value. So it'll turn it into basically like 3 or 4 or 5 or whatever. Oops. So when I run this, it gives us that value. So you can see how this actually converted into an integer. And so I keep running it, and I keep seeing that it's between 1 and 6, as expected. So I could also roll like 100 dice, and so that would give us a value between 100 and 600, which is a lot of dice. And so you can see the superiority of a computer in this, because if you had to roll 100 dice and count all of them and add them up, that would be a pain in the ass, right? And generally people don't like that. So we have a beautiful automation process here. Computers are wonderful at calculating things and doing things for us. So how do people feel about this? Do people understand what we did with each type of function? So we did the first two were the void types. So they did not return anything. They just executed the code inside of them when you called them. The first one, you just call it, you don't give it a parameter inside of it. You just write roll 2 dice, open and close parentheses, like we did here. And then it will just do its thing. So I execute that code inside. And then the second one was also a void function, meaning it did not return anything. So when we called it, it ran this function. So I hope your head's okay there. So it passed that value into here. So it created a new function of the type integer and assumed that value, which was 3 in this case. And it ran this using that. And then the third type, which we did here, we called, it's an integer function, meaning it returns an integer. So we assume that anywhere we call the function, anywhere we write its name, it's going to change that, convert it into whatever type of thing it is. So it calls return some dice roll and passes in the value 100 into how many dice, and then it will return that value, so it'll teleport it back. And so this will be turned into 100 or 150 or 500 or 550 or whatever. And it's inside print line, so it'll send it to the console. I know it's kind of weird, but were people able to follow that? Can we see another 1 to 5 in the chat? 1, I have no idea where I am. 5, I'm a fucking master at this shit. Okay, so is there one that we can go over again? Or what are your questions? Do you have questions about a particular one? Was there one that confused you? Did I lose you at some point? Any of that stuff? Any questions? No questions? Give you like 5 more seconds to ask a question. Okay, so that seems like no questions. So let's say that we wanted to actually, what's your question, Zach? So this thing is based around the random functions. This is just an example. So I'm actually going to show you a different example now. So this was an example of just how you could use this, how it could be useful. So this was just a dice roll. So dice roll is a random type of thing, so that's why it's using random in all of these examples. But let's see another example. So if so here, this is actually the one that we did a few weeks ago together. So where we had the game state stuff, remember? So this is all I did was I just took the one that we did together. So it's not anything weird or anything. So it's just having those various game states, right? So one really great thing about custom functions is it can allow us to organize our code so it's easier to read. So because, like, you know, it's been a few weeks, right? So if you look at this, you're probably like, I kind of remember doing this, but I have no idea what the fuck this is about, right? So when we want to make this easier to read, what we can do is we can actually organize this in a way that makes sense. So we have, if you remember, maybe you don't, but if you remember, game state 0 was associated with the intro or title state. So that's what I said here. So if we want to make this maybe a little bit easier, I can move this into a new function. So I can make a void function. I could call it intro stuff. and then I cut and then I pasted everything from that into the intro stuff. And then if I wanted to run it here, I could just write intro stuff. So now instead of like all of that code in here, it will run this function called intro stuff. So I know that inside of here is all the intro stuff, all the stuff that we want to happen on that initial screen. And so I could have where we know that game state 1 was the equivalent of level 1, the state for level 1. So I could cut all of the contents from this, and I could make a function called level 1 stuff. And I could paste all that level 1 stuff in there. And then I could write level 1 stuff. So now when it gets to this state, it will call the function level 1 stuff. It will run all of this code. And then we have, this was the level 2 state. So I can do the same thing for the level 2 stuff. So I can take all of the contents from here. I can cut it. And I can make one called void level 2 stuff. And so I pasted in the contents, and then I can write level 2 stuff, semicolon. And so we didn't really do, in this example, we ran out of time, so we didn't really do the other ones. But like you can see that, like the way we have it right now, we basically like moved everything and organized it in a way that's really easy to understand what's happening with this. So when we look at draw, we can see that if the game state is equal to a value of 0, it's going to execute all the code associated with the introduction, right, or the title screen. We know that if the game state is equal to 1, it will run all the code associated with level 1 stuff. If game state is equal to 2, it will run all the code associated with level 2 stuff. And I could keep doing this if I wanted to. But you can see how like it's much easier to read this amount of code than it is to read like all of this stuff back together over here. You know, like how we had it when we started? It's like a lot of stuff to get through. But when we have it this way, it allows us to understand like abstractly what's happening in a very simplified way. Does that make sense? Does that make sense how this is making it easier to read, easier to understand, more organized? If not, let me know. Do people see how this could be useful? Cool. Are there any questions? Does this, Zach, does this help clarify how this is, how this could be used besides just with the dice roll? Okay, so awesome. All right, so the next thing is that I want you all to know so like you're supposed to think about a weird animal, and then the other thing you're supposed to think about was an awful job. So you know, hopefully you've thought of something by now. So I want you to give those in the chat. Give your weird animal. So everyone needs to do this, or else it's going to be randomly assigned, and you're not going to. You don't want to get a weird animal that you don't know. So your weird animal and your awful job. So put them in the chat right now. Weird animal, awful job. Horse jerker. Okay, I don't know what that is, but okay. Groundhogs all day herd. So, and then what's the job associated with that you picked? So you need both, right? You need your weird animal, and you need an awful job. Okay, platypus retail. Retail is awful. Awful, worst jobs of my life. Hedgehog accountant. Accountant is, These are all subjective, but yeah, I would say that's a horrible job. So keep them coming. We need to see one from everyone. Okay, okay. I don't know what a sparkle muffin is. Spackle muffin, sorry. I'm like, should I know what that is? And a tax collector? Eve Coon? Is it like a reference to something? It's a reference to something I should know, isn't it? It always is. Flopfish, taxi driver. Porcupine, McDonald's. iCar. iCarly. I'm gonna pretend like I know what that is. Yeah, I know what that is. Cool, so have we gotten everyone's? Let's see. David, did we get yours? Oh, Nate's here, hiding. Cucumber God, okay. Everyone's got a job, right? So we need everyone to write theirs in. So otherwise it's gonna be bad for you. I mean, if you write it in, you're good. So I'll give you like, what, like 10 more seconds, maybe 15 more seconds. Weird animal, awful job. I'm doing this in a weird way. It kind of hurts. I don't know if that was 10 seconds, but it was, I just counted down from 10 using my fingers. So if you did not write one, I'm going to assign one to you. Okay. So you're probably wondering, why did we just do that? What was the purpose of that? Why did we pick a weird animal and an awful job? Does anyone want to guess why? Does anyone have any idea why that might be? To wake you up? I mean, if it helps wake you up, that's good. But that's not why. You're gonna cosplay as them? That's not gonna be associated with the class. If you want to cosplay as them, that's on your own time. So TJ said for homework. So I said that, I mean, why not? You could be like Sonic or something. Shadow's so cool. So the reason why you did this is because you have now just chosen your final concept for your final game. So your final game, your final project is going to be based around the weird animal you picked doing that awful job. So like if you picked like a walrus carpenter, your game is going to be about a walrus being a carpenter and what they have to do. Maybe they have to, like, I don't know, nail boards in or something. I don't know what carpenters do. So that's your final concept. So did anyone think that that might be it? Anyone suspect it? Because that's what it is. So I hope you have something you like. At least you have something that interested you at least a little bit. So the idea is that everyone has a very different concept and everyone has to like really think about like how to do it. So this is your final game concept. So you're making a game about that weird animal. And also weird animals all operate in different ways. So some of them swim, some of them walk, some of them climb or slither. I don't know what animals do. And then doing that job. So like, you know, if you had like a writer who is like a slug, then you know, like how they write, like with a pen or something, is going to be very different than like a spider who writes. They can have like 8 pens in each hand. Well, I guess they need to like, yeah, 8 pens in each leg to like write, and they can write at the same time. So that's your concept. You're going to have to actually, next week, you're going to be pitching your game concept. So you're going to have a prototype or a mock-up of your final game using the concept that you chose. So you have your, and so this is going to be a presentation. So everyone is going to be presenting to the class their concept. And yeah, so you're also going to be using libraries for the final project. So we have like what, 4 weeks left of the semester, I think. So it'll be at the end of the semester. So you'll have your pitch next week, and then you'll have 2 prototypes for the final project, which you actually like show it working and you make progress on it. And then you'll have your final presentations where you present that final project at the end of the semester. And so all of the remaining assignments are related to the final project. So one thing is that people are going to have to get familiar with libraries. So we haven't used any libraries in class. So I'm just gonna like show you an example of how you might go about that. So if you go to Sketch at the top and go to Import, you can see a list of libraries that are included in processing. So like for instance, video is a library included in processing. So if you do that, it will basically give this piece of code at the top, which will allow you to unlock new features, new ways that you can use stuff. So if you go to File, Examples, and then you scroll down to the libraries folder, and then I could go to, sorry, this is really small for some reason, video. So like I can see examples from the video library. So some of these are included. So if I open this, it gives me the code for an example. And so if I run this, and this is a reverse playback example. And so video functionality does not like automatically come with processing. It's something that has to. And so it's playing this video in reverse. So like you can see examples of the different kinds of things you can use with libraries. So it adds the functionality to play this video, for instance. I could then look at like, let's see some other video examples. Scratch, I don't know what that does. Let's see. So it's like scratching I don't know, a record. So where I can move the cursor and it controls the playback. And so you can see all of the functionality in there. You can see like if you go under Sketch again and go to Import Library and then go to Add Library, you can see that there are a whole bunch of user contributed libraries. And so you can look through and see what some of these are. So there are ones for all kinds of different functionality. One of the really cool ones is you can see stuff for like different kinds of controllers and stuff to use your camera. Really cool post-processing effects to do like really fancy things. Motion tracking. And so if we go to Box 2D, if you install this one's actually a physics simulation library, so it adds a lot of physics functionality. So I already have it installed, but if I didn't, I would hit install. In the bottom right, it would install that library, and then I could then go back to the examples if I wanted to see one. And then under contributed libraries, these are the ones that you install separately. And so I see Box 2D, so I can just show you some examples of like what this library can do. And so this is like a liquid example. So it's showing you how this like can simulate liquids, which is pretty cool. It's very small, but you get the idea, right? So I click and it adds a new source. Let's see what else. Bridges? I don't know what this does, but let's find out. So I can run this bridges example. And so I'm like spawning a whole bunch of little shapes, and it's showing how this is acting as a bridge, holding it up with different supports. And so there are all kinds of libraries that do very different things and add a lot of functionality to processing. So there's also like ones for audio, such as Minim and sound. These are two separate audio ones. There are, let's see, I also have PostFX installed. So I'm just gonna run this and see what it looks like. Not all of the libraries are awesome, but some of them are awesome. So you can actually have 3D stuff in processing as well. And so I want you to just like check some of the stuff out, because you're gonna have to use one library in your final project. So people usually use the audio ones, but I want you just to explore and just see what's available. Another one is like Control P5. I'm just gonna install this one. So again, to get to the libraries to install, you just go to Sketch at the top, Import library, add library, and then you can see the list of all of them. And this one is now installed. And so let me see if I can go back to the examples. Let's see if it refreshes on its own. So I think I have to actually, to see the examples, I would have to restart processing. But if I use that one, Control P5, that's actually a user interface one, so you can have buttons and like sliders and stuff really easily. So yeah, so that is what you're going to be doing for next week. So you're preparing your mock-up or prototype and your presentation to pitch the game based on your animal that you chose and the job. And so you'll also need to indicate which library you want to use for your final project, so you'll have to explore in here. So you cannot change your job. Although since you're not a student in the class, you technically don't have to do the project, but if you want to, you're welcome to. But no, you can't change your job, sorry. Cool, so are there any questions about what we're doing so far? So you have your final project concept. You just need to prepare your pitch, your basic idea of like, how are you going to execute this in code? So you don't have to have, obviously you don't have to have the final project done yet, but you have an idea that you're presenting so you can get feedback on it. So the final will be due finally at the end of the semester. So you'll have little stages where you have different prototypes showing they're making progress on the final game. So for next week, all you have to have is your pitch where you're presenting the idea of your game with some kind of mock-up or a working prototype to convey what your concept is, like how it's going to exist. So if you want to make a mock-up, you could just make it in Photoshop or something just to show what it would look like as far as like how the interactions are. So when you explain them, it acts as a visual aid so people can better understand it. Are there other questions? Any other questions? I'm waiting. So we're not going to code this. So for next week, if you want to code a prototype, I encourage you to do that. But all you need is a mock-up. So mock-up or a prototype. So mock-up is just like showing people. It doesn't have to function though. And so you will be using some kind of library for this final project. So you don't have to use it yet, you just need to know which one. So you need to explore the available libraries to figure out which one you want to use. So that when you pitch it in your presentation next week, you'll be able to explain what it is and how you're going to use it in your project. I have so much stuff open now. Any last questions? So we're almost at the end of the semester. So a mock-up is just a, like you have like a mock-up, meaning you're just showing what it would look like to give an idea. So like, you know, if you were to like, for instance, if I was to do a mock-up of processing, I might get like a sheet of paper and just sketch out like the window. I might sketch out like the little minimize button, the maximize button, and the X. And then I might like write some code inside of it. And then I might like, you know, draw the play icon on the side, but it's still a sheet of paper. So you can't use it, but it can help you explain what each of those things are and what they do. Does that make sense, TJ? Yeah, if you wanna do it on paper, you're welcome to. Just make sure that you're able to show it in your presentation. So if you want to use video and then you can just hold it up, that's fine. As long as it's clear. Okay, so it is 1:46. So if you have any questions that come up, just hit me up on River. And yeah, so that's it for today. So I hope everyone stays sane throughout the next few days. So I will see you next week. If you want to draw a character, you're welcome to draw a character, but make sure the mock-up is showing the functionality of it. So cool. So we have time, but we're approaching the end of the semester. So have as good a day as you can.